Now, in this question, it wants to know which of these drawings shows a hydrogen bond. And what a hydrogen bond is, it's an intermolecular bond. And intermolecular bonds connect two different molecules together, kind of the same way that the internet connects two different computers together. These hydrogen bonds are going to connect two different molecules together. And so there's two different criteria that have to be met for a hydrogen bond to exist. And the first criteria that has to be met is that the hydrogen in the hydrogen bond needs to be bonded to a N, O, or F. And so we have to have this criteria met first. And the next criteria that has to be met is that the hydrogen in the hydrogen bond needs to be bonded to another N, O, or F. Now, it's important to know that this N, O, or F right here, this does not need a hydrogen bonded to it. And so let me show you an example of what this means. Let's say that we have something like H2O. And so I'm going to have H bonded to O and then bond it to an H like this. And so this is a water molecule. And let's say I have another molecule over here, something like oxygen, and it's double bonded to something like an S right here. And so what we have here is an H bonded to an O. That's going to meet this criteria right here. The H in the H bond, which would be right here, is bonded to an oxygen right here. And what makes this so unique is the fact that oxygen and hydrogen, they have very different electronegativities. And it means that in this bond right in here, it has electrons in there, and these electrons are going to be more attracted to that oxygen than the hydrogen. And so they spend more of their time closer around the oxygen, which makes this oxygen going to be delta negative like this. And as a consequence, this H right here is going to be delta positive like this. And so we have this negative positive polar molecule right here. And then what we have is oxygen is going to be right here. And oxygen also has a very electronegative charge right here in this one. And so what can happen is this hydrogen right here can be bonded to this oxygen right here. And this right here is the intermolecular bond or the hydrogen bond. So this is the hydrogen bond. Now notice that this oxygen right here is not bonded to an N or F, it's bonded to an S. And that's okay because in this criteria right here, it says that this oxygen right here doesn't have to be bonded to an H. It can be bonded to basically anything as long as the H right here that's involved in the hydrogen bond is bonded out to an oxygen right in here. And so now what we can do is we can look at this information in here to figure out what the answer is up here. Now, if you look at this answer choice right here, we have H bonded to an H. And in this criteria right here, an H needs to be bonded to an N or F, so it can't be this one. And if we look over here, we have an H bonded to an F. Well, that means this criteria right here, this can do a hydrogen bond, but it's not showing another molecule because we need the H that's in this hydrogen bond right here has to reach out to another N or F. And so the key thing about this is it has to be another N or F, and this bond to the same one. So it's not going to be this one either. And if you look at this one right here, we have an H right here, and it's bonded to an oxygen right here. So it meets this criteria. It's bonded to the oxygen, and then it's going to reach out and it's bonded to an oxygen right in here. And so this right here is the hydrogen bond. This is the hydrogen bond. And a common mistake is students will often think that maybe this right here or maybe this right here is a hydrogen bond. Those are covalent bonds, and a hydrogen bond is a type of intermolecular bond that's going to occur between two different molecules like this. And so the answer choice is going to be C.